Sophia, and I'm going to talk to you about naming ionic compounds. This is mostly for an AP version, so I'll be assuming that you know what polyatomic also transition metals. So remember that an ionic compound is metal and an ion. It's also important that you memorize tables 2.3, 2.4, 2.5, putting references in the video as well that you can use. So if I have a compound like this, I have Pb parentheses C2 H3 O2 parentheses 2. Now, it can be daunting if you haven't memorized this table, but it's very helpful to know that the acetate ion is C2H3O2. Okay, so I know that this is lead and this is acetate. So my answer is probably going to be lead acetate. All right, so let's keep going. And when I look at my periodic table, I go to find lead, and it is way over here. And lead is one of those metals, but it's also considered a transition metal. Okay, it can have two different oxidation states. So the lead can be a 2 plus, or lead can be a 4 plus. So this is why it's important to memorize these, because you need to memorize both oxidation states and know when to use the right one. So if I know that I have an acetate ion, C2H3O2, in parentheses, this is a minus ion, because when I memorized this, I memorized also that the charge was a -1. Now, I know that there are two of them, so I'm going to multiply this by 2. That multiplies all the masses by 2, but it also multiplies the charge. So my total charge is now going to be a 2 minus total charge. Okay? I also know that the charges have to equal out, and the net charge of the whole molecule needs to be 0. So if I know that the acetate is a 2 minus charge always, then that means that the lead must be a 2 plus charge. So the way I notate this is by writing lead 2 acetate. That means that we have lead, Pb, 2, meaning the 2 plus. Okay, this Roman numeral means the oxidation state. It never means the actual number of molecules. And then the acetate is just because it only has one charge, we don't need a Roman numeral. You'll see Roman numerals when you see transition metals, or whenever you see something that has more than one oxidation state. Now let's see if we can check for comprehension by taking CuSO4. That is going to be copper 2 sulfate, because the copper 2 applies to the 2 plus charge. Sulfate is the SO4. So sulfate always has a 2 minus charge, so the copper needs to be a 2 plus charge to balance it out. If I were to do it the other way and put a name up here, I would need to find the formula for it. So magnesium is Mg, and I know that because magnesium is here in the periodic table. It's in the second group, so that means it is a 2 plus charge, and 2 plus charge always, it's not a transition metal. And the hydroxide, which I memorized, is a minus 1 charge, so that's why there are 2 hydroxides in the answer. Along the same lines, if I had calcium sulfate, I know that calcium is Ca, and it is in the second group on the periodic table, so it is a 2+ charge. Sulfate is a 2- charge, and it is CaSO4. If I had CaO, I would look at calcium on the periodic table and know that it's in group 2, so it's a 2+ charge. And then I look at oxygen is in group 16. Remember what these charges are? Remember these charges are 0, -1, and -2. So I have a 2+ charge here and a 2- charge. Those two charges, a 2+ and a 2- will balance out so that I don't need any Roman numerals. It just makes calcium oxide. It's Mr. Russell, and I want to tell you about naming molecular compounds. You might say, Mr. Russell, what the heck is a molecular compound? Well, that's a covalent compound. These are all covalently bonded. We'll be using the Greek prefixes for these, and it's going to be awesome. So if I have something like P2S5, the least electronegative is going to be the one that comes first. And you might also say, Mr. Russell, how do I know which one is the least electronegative? Well, that's always going to be the one that's to the left. We have phosphorus and sulfur. So phosphorus is the least electronegative of the two. So I have 2 phosphorus and 5 sulfurs. So I'll use the Greek prefix and call it diphosphorus pentasulfide. Di meaning 2 phosphorus, and penta meaning 5. I also changed the last letters. I changed the ending to an I. So that will always happen, and we'll always use the Greek prefix. Along the same lines, if we have B2O3, that will be 2 borons and 3 oxygens, so that will be diboron trioxide. The di meaning 2, and the tri meaning 3. So you may run into a situation where the first one does not have a number, or it only has one, like this one. It has 1 sulfur and 2 oxygens. So when I do that, and if it's the first one, I just don't do anything to it. I just leave it as sulfur dioxide. So without any Greek prefix at all, if it's the first one. But I still changed, I put the di in front for 2, and then I changed the N, IDE, to make it sulfur dioxide. So now, if I have something like this, if I have N2O, the first one has 2 nitrogens, but the last one has only 1 oxygen. So this one only has 1. So I'll still have to use a Greek prefix for both of them. I have to use the Greek prefix for 2 and 2, but I'll also use the Greek prefix meaning 1, mono, for this one. If you wrote this out, if you wrote out monoxide, you would actually have 3 O's or 2 O's in the middle. So we actually just dropped one of those O's. So it sounds better. So dinitrogen monoxide. some extra checks. If I gave you the name instead, you would need to know that this is sulfur, and there's only one sulfur, and there's hexachloride. So that means there are 6 chlorides. So that means that I need to have SCO6, hexa meaning 6. Also, if I gave you the name here, arsenic pentafluoride, this arsenic meaning 1, and there's no Greek prefix, so there's 1, and penta meaning 5. So that would be AsF5.